Hi students, this is Vani working as assistant professor in physics in Siddhartha Institute of Science and Technology. Today we will discuss a topic of diffraction. In yesterday's class we will discuss about interference. So in today's class we discuss what is diffraction. So diffraction. So how many types of diffractions? So what is the differences between interference and diffraction? What are the differences between Fraunhofer diffractions and Fresnel's diffraction? Some little applications of diffraction. So diffraction means the bending of light waves. The bending of light waves around the corners of obstacles. So we are taking an obstacle here. The light bends at the edge of obstacles. That is called as a diffraction. So which is also another phenomena of wave nature of light. So in the wave nature of light, interference is one phenomena. Another phenomena is diffraction of light. This diffraction is coming from the Latin word. Diffraction comes from the Latin word which comes from the Latin word diffractus. Diffractus. Diffractus means break into pieces. Diffraction means break into pieces. So let's go for the differences between interference and diffraction. Interference and diffraction. Interference is due to the superposition of two different waves. Superposition of two different waves coming from coherent sources. Superposition of two coherent waves coming from two coherent sources is called as interference. Diffraction due to the superposition of secondary wavelets. Superposition of secondary wavelets from the parts of same wavefront. From the same wavefront, secondary wavelets are generated. That superposition of secondary wavelets is called as diffraction. Next, in the case of interference, fringe width is constant. Fringe width is constant, but in the case of diffraction, the fringe width is varying. So when the order of the fringe increases, the intensity is decreases. That is observed in the case of diffraction. But in interference, it is equal. So the width is equal. In diffraction, the width is decreases when the order increases. The intensity also decreases when the order increases. Next, another difference. All the maxima have the same intensity. All maximas have the same intensity. Here, the maxima are of varying intensities. This is a diffraction. Next, there is a constant phase difference between maxima and minima. There is good contrast between maxima and minima. There is a poor contrast between maxima and minima. This is about differences of interference and diffraction. Interference means superposition of two different waves coming from the coherent sources. Diffraction is the superposition of secondary wavelets from the different parts of same wavefront. Next, go for diffraction. Diffraction is divided into two types. Diffraction divided into two types. One is Fresnel's diffraction, another one is Fraunhofer's diffraction. So Fresnel's diffraction and Fraunhofer diffraction. So what is meant by, so this, just to briefly discuss the differences between Fresnel's and Fraunhofer diffraction. So in Fresnel's diffraction occur the light source and screen are at finite distance. Light source and screen are at finite distance. That is called as Fresnel's diffraction. So in the case of Fraunhofer, the source and screen are at infinite distance. To observe the interference pattern, we place the screen. So that screen and source are at finite means that type of diffraction is called as Fresnel's diffraction. That are in infinite distance means that is called as Fraunhofer diffraction. Next, in the case of Fresnel's diffraction, lenses are necessary. We have to use the lenses must and should to form the diffraction pattern in the case of Fresnel's. But according to Fraunhofer, we don't use lenses. Lenses are not necessary. Study of diffraction is complicated in the case of Fresnel. Study of diffraction is complicated in case of Fresnel. Study of diffraction is easy in Fraunhofer. Next, diffraction can be studied in the direction of propagation of light. Diffraction is studied in the case of in the direction of propagation of light. Diffraction is studied in any direction of propagation of light is called as Fraunhofer diffraction. In the case of Fresnel, the incident wavefronts are either spherical or cylindrical. Incident wavefronts are either spherical or cylindrical. In the case of Fraunhofer, the wavefronts, the incident wavefronts are plane. The incident wavefronts are plane. So this is about diffraction and types of diffraction. Next we go for diffraction grating. So in the case of interference, we use a single light source is going through two slates. That superimposition of light rays will give the interference pattern. So here diffraction grating has a number of slits. In this diffraction grating, number of slits are there. That number of slits are separated by equal spacing. That number of slits are separated by equal spacing. This is about diffraction grating. Here they mention 15,000 lines per inch. Per inch 15,000 lines are there. They are also separated by equal opaque spaces. In equal distances, the lines are equally separated. This is called as diffraction grating. When the white light falls on the grating, we observe a spectrum. So spectrum means different colors. So Vibzier colors is formed. We will find the wavelength of that colors also by using this diffraction grating when the light falls on the grating. Next, by using this diffraction grating, we find the wavelength of light. Determination of wavelength of light by diffraction grating. So how we find means, when a beam of light falls on the grating, it forms a spectrum of orders. So that orders are called as n is equal to 0, 1, 2, 3 like that. So there E plus D into sin theta is equal to plus or minus n lambda. That is the path difference. So E is the distance of the width of the slit. E is the distance of the width of the slit. D is the distance between the slits, and n is the order of the spectrum. By using this formula, we can find the wavelength. So n into E plus D is equal to 1 inch. So 1 inch means 2.54 centimeters. This E plus D is called as grating element. E plus D is called as grating element. So from this, E plus D is equal to 2.54 by n. So n is the number of lines in that grating. So here in this grating we can observe how many number of lines here? 15,000. In some gratings we are using 2,500 lines per inch. So that number I have to mention here in this formula. By that we calculating the wavelength lambda value. So this is the determination of wavelength of light by grating. Next, so applications. In real life we can use the diffraction. We can observe the diffraction in the case of lasers and CDs, DVDs. We can use, that means we can observe the diffraction where the diffraction is observed. Next, recording of 3D images. Next, study of DNA and RNA also we use the diffraction. Holographic memory also. Here also we can observe the diffraction grating. In X-ray diffraction, electron diffractometer, Newton diffraction, we can observe the diffraction. So in experiments, spectrometers, we are place the grating on the spectrometers. We can find the wavelength of colors. That means VIBGYOR colors, violet wavelength, red wavelength, all wavelengths we can find by using this diffraction grating. So this is about the applications of diffraction. Thank you.